Now what we'll do is use that function notation to help us evaluate a few different examples relatively quickly, where what we're doing is calculating simple interest and payoff amounts for loans. We're going to need two different formulas here. The first one is the simple interest formula. So total interest accrued is going to be equal to some principal amount times an interest rate times the length of time of our investment. So R is always going to be a percentage, which we can convert to a decimal for our calculations. And for this formula, time t is always measured in years. The second formula that we want is one to calculate the payoff amount. The payoff amount is how much we'll have to pay at the end of the period of our loan to have fully paid our debt. So the payoff amount is going to be equal to the principal, so the original amount of the loan, plus any interest that we've accrued over time. Interest is that simple interest formula, so we could expand this out to write it as P plus PRT. Flipping over to Desmos, we can set both of those functions up. First, we'll start with our interest formula, which has three variables, capital P, lowercase r, and lowercase t. And that formula is equal to PRT, or that function is equal to P times R times T. And then we have our payoff amount formula. We can't use capital P to name the function because P is a variable in the function. So I'm going to call this A. And this function has exactly the same three variables in it: the principal, the interest rate, and the time in years. All that changes is we're taking that interest and adding it to the original principal amount. Now we've constructed those two functions in Desmos, we can use those to pretty quickly move through examples 5, 6, and 7. What we're asked to do is calculate the simple interest and the payoff for a loan with some given parameters. So looking at the first one, we'll start off by calculating the interest by typing in I, so we're calling on that first function that we created. Our value for P, the principal, is $6,372. The interest rate is 0.1125, and our time in years is 8. So that gives us an interest rate, an amount of interest accrued of $5,734.80. We have two different ways to calculate the payoff amount. We could either manually add that interest to the original principal, or we could evaluate that payoff amount function that we set up with the exact same values. To get that our total payoff, which is the interest plus the principal, would be $12,106.80. The next two examples, 6 and 7, will be very similar. We'll just update those given values, but they have an extra step in here that we need to look out for. In example 5, t was given to us in years, but in example 6, time t is given to us in months, and in example 7, in days. What we need to do then is convert those values to both years and days. Convert both of those values to years. To do that, we'll take our number of months divided by 12 and our number of days divided by 365. Other than that step, these two problems will be exactly the same. And we can flip back over and just update the values that we already entered in for both formulas. So for example 6, we had an initial investment of $5,315. An interest rate of 5.75%, and now our time period in years will be 27 divided by 12. So our total interest will be $687.63. And that payoff amount will be $6,002.63. Repeating this same process for example 7, again, we'll just update these amounts. Now we have $3,888 that we're investing at 8% or 0.08 for 32 days. So to convert that into years, that will be 32 over 365, giving us an interest rate of $27.27. Updating that payoff formula with these same values gives us a payoff amount of $3,915.27. So again, using Desmos is allowing us to quickly evaluate that formula over and over again without having to type in all of those values. The key thing that we need to look out for here is how time is being given to us. If it's being given to us in months or days, we just need to update those values, adjust those values accordingly.